All right, we are back to the Back to the Future. Next presentation, like I said, Srivali Aparna. So are you ready for better results analysis? So like I mentioned, Dane, Stephen, even during the last WAPR, there was a lot of discussion about the analysis and the importance of raw data. So everyone expects to have the raw data to have a better vision of to analyze and make decisions that make sense. And one of the tools, the preferred choice tools so far exposed is Tableau. And Srivali mentioned is make the point. I mean, if you don't want to utilize a tool like Tableau, which could be expensive, maybe we could figure out another solution to analyze. And Srivali is going to talk about it, and he's going to mention a solution called R Studio R. So I discovered that through Srivali. So thanks for that, and I'm pretty excited to hear about the tools and how to use it and what are the advantage, also the disadvantage of the tools. So that would be pretty cool. So Srivali, so I don't know if you, for those who's joined us, Srivali is the second pack. So she joined us for the virtual pack last year, and she was with us as well in Chamonix in the Alps. So Srivali is a test consultant working from Oakland. She is very modest, but she's a pure expert from my perspective. She's been working in this recent several years. She knows a lot of stuff about database and performance testing. So if you have any questions or any things on any recommendation, you can reach out to Srivali on LinkedIn. She's well connected. Otherwise, she's been involved in the WAPR 26 in Melbourne, I think, if I'm not wrong. It's so yeah, Srivali is so if you want to learn more about the analysis, Srivali is going to go through that topic. And thanks, Srivali, for suggesting this topic, because I think it's pretty interesting, and a lot of people is eager to learn more about the R as it is.
Yeah.
So I'll let you present, and I catch up in 30-40 minutes. So enjoy, and talk to you soon.
First of all, thank you, Henrik, for the introduction, and as well as for this opportunity. This is my second virtual pack, and I'm quite excited to be part of this pack community. So hello and welcome everyone to this presentation. I think the title of my presentation, and Henrik has already given the context, so it gives away what I'm going to talk today. So it is a running joke in the performance testing community on how still some performance test users are not using raw data for analysis. But on a slightly serious note, this is a real problem, and it has been highlighted by some of our PAC experts in the previous PAC sessions. So we understand the problem of the limitations, rather, of the aggregated data. So the goal of this presentation is hopefully to make data analysis more accessible and fun for performance testers. Because I think at the end of the day, data analysis is a really crucial skill these days, not just for performance testers, but pretty much for anyone, because of the huge influx of data that is generated by various systems. So let's just make use of the data that is available. So this is a sample output graph from JMeter. there is nothing wrong with this graph. It is a perfectly decent chart with timestamp on x-axis and response times in milliseconds on y-axis. But when I use something like this for analysis, it is slightly distracting for me. I'm pretty sure most people would agree with me here that when analyzing, I'd like to look at one thing at a time. So instead of looking at predefined set of charts or tables, I'd like to explore the data. So just to give you an idea on what typically goes on here at a high level when I'm analyzing the test results, say, there are, of course, certain things that I commonly look at in every single test. Like for instance, okay, I look at throughput to make sure that it's a valid test and it has met the expected throughput, and I look at the response times, errors, or resource usage, etc. But that is only at a high level. The actual detailed step-by-step analysis, it varies from test to test. So I wanted a tool that will help me do this. And I have been using Tableau for a few years now, and I really like Tableau, and it's powerful, it's flexible, but obvious downside is it's a paid tool, right? So I have been looking at the open source options, and because at the end of the day, I think our skill set should not be tied down or limited to a specific tool. So that's why I was exploring other options. And so my reasons for choosing R are it's programming, so it's fun and flexible. And R was developed specifically for data analysis, so which means it comes with a huge collection of statistical functions and packages that will support exploratory analysis. And of course, it's free. And I'm a proud alumni of the University of Auckland, and R was originally developed at Auckland Uni. And R comes with quite a few handy visualization libraries that we are going to briefly touch upon towards the end of this presentation. So with that said, let's move on to more interesting demo stuff. So let me briefly introduce the IDE that we are going to use today for this demo. Before I move any further, let me just make one thing clear. I don't want to make this presentation like a generic beginner's R tutorial. I want to keep this very specific to performance testing. So the things that we look for in the problems that we face as testers and performance engineers. So I think the key takeaway, the end goal for me is that hopefully by the end of this presentation, if I could get at least a couple of people excited about data analysis, and if they are able to use it, immediately apply it in their day-to-day performance testing activities. I think that would be the best outcome for me. So yeah, let me introduce RStudio. So it has 4 key sections. This is where we write the script, we write the code, and it has got an environment section. So if I load any data set into our session, this is where we can see it. And we have a terminal output, and we have a place where we can see the plots that we build. So if we build any charts, it has multiple tabs, but this is where you can see here. So let me begin by opening RStudio. So as you can see here, the environment section is currently empty, so there are no data sets that are currently loaded. So let me quickly load so I'm going to use a sample output from JMeter for this demo. So R supports a variety of data sources, but for this presentation, just to keep things simple, I'm going to use a simple CSV file. So I'm going to use read.csv. The file is in my current directory, so I'm not specifying the full path. And yes, it has headers, and it is a comma separated file. So let me load this into a variable so that we can reuse it further. So when I run this, as soon as I run this, you can see it has been loaded into the session, into the environment. I'll open the file, the data frame, and I'll show you what's inside it. So it's pretty much familiar for every performance testers, engineers, because not just for JMeter users, it's pretty much the standard format. We have the timestamp, which is an epoch format here, and the elapsed column, which is nothing but the response times in milliseconds and transaction names, response codes, thread groups. So the success column here, if the transaction is successful, it's true, otherwise it's false, and a bunch of other information. So the way I want to structure this demo is I want to begin with some really basic commands, and then move into slightly advanced, interesting stuff. So just to take a look at what inside it, I think nrow and ncall are like the really basic R functions, which means the name is obvious. Nrow is nothing but the number of rows, and ncall is the number of columns. If you have noticed already, it is same as what is here. It's the number of observations. It's nothing but the number of records. Let me show you a slightly interesting function. So str function, if you are like me, coming from a different programming language, typically str stands for string. But in case of R, it shows the structure of the data set. Like when I run this, let me expand this. As you can see here, what it does is it shows for each and every column in my data set, it shows what is the type of data in it. So here, the interesting thing is factor. Factor is nothing but a categorical variable. Like for instance, marital status. So it either married or unmarried. So in this case, say response code is a categorical variable because it has like 8 different levels in it. So if you want to see what are the unique values in it, we can do something like this, data frame name, and then as soon as you enter $, it will prompt with all the columns. Yeah.
We are still seeing the sample data table. We don't see the structure that you're talking about. I don't know if there's a lag, but I don't see the structure that you described.
Okay.
The data frame is visible. I don't see it. So maybe.
Okay, you don't see anything on my screen.
At the moment, I see the sample data table.
Oh, okay. I'm not sure what's wrong, but I can quickly stop and restart sharing if that's okay.
Yeah.
Yeah, sorry. Share screen. Yeah. Is it do you see anything different?
Yes, perfect. Now we see the console screen.
Okay. Okay, yeah. Let me start with the recent one. So, the str function is what shows the structure of the data set. Like what it shows is for each and every column in the data set, it shows the type of data stored in it. So the factor is one of the interesting type of data. Factor is nothing but a categorical variable. So what I mean is that, for example, whether here success is true or false, it's one of the 2 categories. So it has 2 levels in it. Similarly, response code has like 8 different levels in it, which are like 8 different possible values in it. So if you want to look at the values within each category, you can do something like this. And as soon as you enter $, it will prompt you with all the columns present in that data frame. So I select the response code. So now you can see all the unique values in it. The reason I'm highlighting this factor is because it will be really handy, especially when we want to filter the data set. Like for instance, when we build a plot and we want to filter it for a specific transaction or a specific error code. So that's when these factors will be really handy. So let me show just one last basic function before we move on to slightly advanced stuff. So summary is it's kind of limited for what we want to do in performance testing. What I mean by that is, say for instance, if you want to get a feel for the response times, how the response times were during the test, you can try doing this, but it is very limited because obviously it's aggregated and it's aggregated for the whole data set. So instead, when we are analyzing results, we may want to look at the response times for individual transaction, right? So for that, there are so many ways to do it in R. The easiest way I found is like using aggregate function. It accepts 3 different arguments. First one is the column on which you want to apply the aggregate, and the second is the column using which you want to group the data set, and third is the function that you want to apply. I'm just using a default function in R, built-in function in R. So when I run this, you can see for each transaction, you can see like minimum, 25th, median, 75th, and maximum value. So you can see all the values. But by now you might be wondering, pretty much every single load testing tool shows this information. Why are we even talking about it? There are a couple of things that you can do with this. The first thing is obviously if your non-functional requirements are like specified in a specific percentile that your load testing tool say may or may not report, you can easily calculate it in R. I'll show you what I mean. For example, if I want 95th percentile, I just wrote a simple custom function with the name percentile 95. All it does, it returns 95th percentile. And I load this function, and now let me. Is it still?
Yeah, at the moment I only see the aggregate sample data elapsed list, and then I can see here a group with a 0%, 25%, 50%. So if you have the display has not been refreshed, so maybe if you can.
Okay. Is there a delay or it's not refreshing at all?
It's not refreshing at all.
Okay, that's very unusual.
Maybe you should you stop and retry like you did before. I think it resolved it.
Okay. Yeah. Can you see my screen?
Yes, it's perfect. Perfect, yes.
Thank you for letting me know. Yeah. Hopefully I'll try to. Yeah, I'm not sure what I can do. Yeah, let me try to keep it slow maybe. Yeah. Okay. So we can, so if you want to calculate, say, 95th percentile, we can, so instead of using the default quantile function, now all I'm going to do is like pass my custom function. So let me clean this up and let me run. So as you can see here, now we have calculated the 95th percentile for the transactions. So like similarly, you can apply like any function that you want, either for reporting purposes or for analysis purposes. So there are a couple of problems with the output, if you can see here. Not quite problems, but one thing is the response times here are shown in milliseconds. So maybe for either for reporting purposes or for analysis purpose, if you want to convert it into seconds, you can easily do it. It is similar to a concept called calculated fields in Tableau. So that's one thing, we are going to fix it. And the second issue with this is that typically when any load testing tools report the response time, I'm talking about the aggregates like averages or percentiles. They include the response times for both failed as well as successful transactions. Sometimes it could be a problem, because when a request fails, the response times recorded for that request or transaction, it will be unusually higher or unusually lower than a normal success response. This could be because, for instance, if you have a request that is waiting for the timeout for 30 seconds or 60 seconds, and then it fails, so it will skew the aggregate response times. So for that reasons, if you want to get a true picture, then you could recalculate your aggregate response time numbers by excluding those failures. So I'm going to show that as well in a moment. So first, let's fix the issue with milliseconds and convert them into seconds using calculated fields in R. So to do that, what I'm going to do is specify your data frame name and then $. So instead of selecting an existing column from this list, we can specify a brand new column name. And then enter your calculation here. So in my case, $ and elapsed column, and then just divide it by 1,000. So I have run it, and now when you open the data, if you can see here, there is a new column here, which we have just created. So now it holds the response times in seconds. So we have fixed one of the problems. And similarly, while we are at it, let's fix another issue. So the timestamp here, if you can see, it is in epoch format. But if you want to build a chart, a scatter plot, or any other chart, then it might make sense to convert it into more human readable format. So let's see how we'll fix that issue. So for that, we'll do something similar. Let me load a library into our session. I'm using an external package, which I've already installed. And then yeah. So now let me open the data set one more time, and you can see the timestamp is much more nicer and easy to read.
So it has Ravi, I have again an issue to open the data set. I don't see it. Is there a way that you the refresh of the screen is so it's stuck at the moment. The screen is stuck on library anytime.
Okay. Yeah, I'm wondering if it's any of the shortcuts that I'm using is messing up with the screen share. I don't know. Yeah. Is it better now?
Yeah, display now. I can see the cursor is yeah, it's fine, perfect.
So what I have done is I have used the Anytime library to just convert the sample data into more readable date time. So that was one of the issues that we fixed. And the second one is filtering the data for only success requests, because we want the response times reported to have only success values in it and exclude the failures. So to do that, we can do a filter, and for which and specify the criteria for which we want to filter the data set. So, and so actually the output of this filter, if you look at it, it is a series of Boolean values. What it means that is that the first record in the data set has matched this criteria, and the second one also matched the criteria, and say the nth record in the data set did not satisfy the criteria. So this is just a Boolean output, but to get the actual output from our data set, we can do that by passing this filter to this original data set, which is sample data set. And then now if you say it, the new data set has only 19,000 records in it as opposed to 20,000 because the rest 1,000 are failures. So now if you recalculate aggregate, but using the new data set this time, then let's see that. So instead of elapsed, we are going to use the new column that we have created, and Henrik, is it fine? Can you see the?
Yes, I can see it.
Okay. So now if we look at the output, the new output, it's not only much nicer to see because it's in seconds, as well as originally, if you remember, it used to be 14 seconds and now it's only 13 seconds because we have excluded failures. It will make much more sense when we look at a scatter plot, why it makes sense to exclude the failures. So this is just the tip of the iceberg, right? There is so much more we can do, and not just for result analysis. We can use R for workload modeling, and imagine like collecting data from so many different sources and everything is in different format, and we want to process it, manipulate it, and before we can even analyze it. So that's where R has like reshape package, dplyr package, so many other packages which will be really helpful. So let me take you to a little more colorful and interesting thing, which is the visual data exploration. So for me, when I'm analyzing load test results, not just load test results, anything huge data, if you're analyzing it, it is probably like more easier if you are able to look at it visually. So for that, R has some useful external packages. The ones that I have experimented so far are ggplot2 and plotly. So in this presentation, I'm going to show you on plotly. But I would encourage like people to explore both of them and choose the one they are most comfortable with. So I'm going to use plotly and build a really basic raw scatter plot. And we are going to do some analysis of the JMeter log file. So to build a plot, scatter plot, so it's already installed, so I'm not installing it again, but the syntax is really simple. It's on x-axis, you specify the column, and for y-axis, you specify the column in the data set. So when I run this, hopefully everything works fine. You should see a plot here loaded. Yeah, it is. Let me see if I can make it bigger without breaking anything. So yeah, it's much nicer. So it is a really basic scatter plot, but for me, it's much easier to look at than the default JMeter graph that we have seen earlier. It's just exactly the same data, but when you look at something like this, there are like so many questions that pop into our head, right? Like for instance, what has happened at 12:01? There is this huge spike and all the response times are like really unusually high. And what about this band of response times at 20 seconds? And there is something else also going on here. So you have so many questions in the head, and the next thing is like answering them one by one, right? So what I'm going to do is like I'm going to add a little bit of color to this, not to make the graph pretty, but actually color is the easiest way to add a third dimension to a 2D chart. So that's why I'm going to add color per response code and see if it's because of a failure or not. So to do that, I'm going to write another command, but it's exactly the same as before, except I'm going to pass a new argument, which shows like color code per response code. So when I run it, hopefully you should see a more colorful chart. Yeah. So now if you look at it, you can see that this spike here is caused because of HTTP 503, which means the server was briefly unavailable for that window, which has called the failure. And here this interesting yellow band is because of HTTP 502, which is a proxy error in the environment. And so we have answered some of the questions, but the next question I had in my mind is that when this failure happened or when this proxy issue happened, did it affect all the transactions or just one transaction? So to do that, I'm going to redraw this plot, but instead of color coding per response code, let's just color code per transaction name. So I'm going to rerun this command, and then let me, no. So it's sometimes during screen share, it takes slightly unusually longer but it's usually fast. So as you can see here, when the issue 503 error happened, it has affected pretty much all the transactions. As you can see, all different colors.
It's not so short this time.
Yeah, the site can't be reached. We are stuck to the error that we had with the viewer.
I think it's either refreshing slowly or something. Why does it have happened to me like all the bad things happen to me? Yeah.
There is no bad thing, you know. It's just we want to see your face. So sometimes we compose and we see your face. That's why. You know?
No, how come like Steven's presentation went so well, and I'm like, yeah, it's not fair.
Yeah, because Steven did a little bit challenge. He was using an IDE and JMeter, nothing really complex, you know. Steve? No, sorry, Steve. I'm joking with you.
That makes sense. Can you see the colorful chart now? Can you? Okay,
yes, cool. We do. Yes.
Yeah. So, and these charts, like, they are interactive, so there are quite a few options, and as well as if you click on any of the transaction names or any elements in the legend, it will filter out the ones which you don't need. And because there are like so many data points, sometimes you may want to zoom into a specific area, and then you should be, it's much easier and interactive for data analysis, which is another cool thing. So, I mean, not just for data analysis, R can also be used for reporting because, so because the output charts from graph are like really rich. So for instance, if you look at something like this, instead of presenting the same information in a table, if you present in this format, it will be much more easier, especially for higher level executives, to see something like this and see, okay, there is one particular transaction that has failed more than the others, or even the response times. So it just makes not just analysis, but also the reporting more interesting and more fun. You can even take it to the next level, like you can build interactive dashboards in R using Shiny apps. So which means that it is both reporting as well as exploratory analysis built into one thing. You can, for instance, in this example, I've added just run ID as a filter, but you can have so many other filters, and it's all reactive programming. So if you select a different option, the chart will automatically refresh. So this is the best way if you want to share your results with your teammates, or if you even want to enable your platform teams to do their initial analysis. So yeah, it is the best approach going. And those dashboards are interactive, which means it comes with all the zooming and other functionalities that we have seen. So that's with the demo what I wanted to show today. And apologies for the technical issues. I honestly don't know what went wrong, but hopefully, yeah, it still made sense. Before I wrap up, I have some discussion points from my end, maybe to other PAC members, like just to understand what is their approach for data analysis and what is their tool currently for analyzing data. As well as I have been working with open source tools lately, so I haven't been quite up to date with the other tools. So I'm quite interested to know, like, how are the other tools, like, have they already incorporated this or going in that direction, building this exploratory data analysis features into the load testing tools, and not just for test results, maybe even for workload modeling, if there is any way to generate it automatically by and then convert it into a test scenario. So yeah, I have so many fancy ideas. So yeah, so it's open for discussion. Thank you, Henrik.
I think thanks. It was a pretty awesome topic, to be honest. I had noted down a couple of questions because it brings my interest.
Yeah.
And before I'm going to ask the question, I see Stephen wearing a really very fancy jacket with a very, very fancy T-shirt. So I would like to thank the New Zealand Post Office because they delivered just in time. So he could show up that during the conference. So thanks.
Awesome.
So I was wondering because so I had a lot of questions, but more on the practical way. So I think Reid. So first of all, I didn't know about it, so I learned a lot. So thanks for sharing that. So it seems that there is a Reid Studio. I shared the link, by the way, on chat to reach out to Reid. To the company. They have an enterprise edition and the open source one. So I think they have a couple of packages. So you mentioned Reid CSV. Do you have any idea on the different type of source that you can have? So instead of reading from a simple CSV file, is there a way to read from, for example, this morning Stephen showed us that he was storing everything in InfluxDB, for example. Can you also connect that to an InfluxDB?
InfluxDB, I'm not 100% sure, but I know it can connect to like SQL and other databases. I don't remember the exact like packages on top of my head, but yeah, I think it should be able to connect to Influx as well, but I need to check. Yeah.
So so in more on a practical level, let's say I want to merge Stephen's topic and your topic. Let's say I'm doing a pipeline, I am storing something in database, and then I want to prepare the visualization. So I'm doing all the value stream boxes that Stephen mentioned. So let's say I have this R I don't know how you call it, R script, or how do you call it?
Yeah.
Yeah, okay.
Yeah.
So I have this R script that will basically go through the data that I have collected or that I have gathered through the test, and I want to change it or change the structure to be able to analyze it. So then if I use a plot, for example, the plot line that you were using Plotly, how is that could be exposed? Is there it seems that it was referring to a local host port with a specific URL. So if I prepare a dashboard that I prepared, can I easily share it to the other members? As you took the example of the websites. But let's say I want to do it in Jenkins.
I mean, there are multiple options. Like, I haven't like fully developed the framework yet, but obviously one thing is to, running your R script on the command line. So R can generate the images and save it to the disk. So one way is at the end of the test, you can generate your predefined set of reports that you commonly look at. And if you want to integrate with the dashboard, that can also be done. So this is like really, in this case, the dashboard, it's just on my local machine, so it just spin up on the fly with the port, whatever is available, but it can be like properly hosted using open source Shiny server, and then you will have like a proper web server running, and every time you run it, it'll update your dashboard with the results, so it can be done.
Okay. And is there a limitation? So if I'm using the open source edition, can I do like sort of like a central server that orchestrate the pipeline, collect the data, and generate those graphs or the dashboards? Is that possible with the open source edition, or do you need to go through an enterprise version? Do you have any idea on that point?
Not completely. I know that open source, open source does support if you are able to host your own web app, but there are other cloud options as well from RStudio, Shiny, if you want them to host your dashboard. But I'm pretty sure locally you can have your own web server app set up. It can be done. I haven't like 100% like tried it yet, but my understanding anyway that it can be done. So.
Okay. And then you mentioned Plotly, so it's like if you want to deploy, it's like a Python package that you install on top of R, or
yeah, it is a JavaScript package originally, but yeah, it is available in R. So you just install it like normal any other packages from RStudio or and then you just need to load into your current session, and it's pretty much like any other normal R package. It works, yeah.
Okay, pretty cool. So I don't know. I'm pretty. Thanks for sharing this.
No problem.
It brings me a lot of ideas in my mind. So thanks for that. So I have no other questions for now. I need to try it on my end, and probably once I try it, I will have lots of questions after that.
I thought it was fine enough to follow. I wasn't sure how bad it was. So yeah.
So I see that Philip is connected.
Yes, hello.
Stephen as well. So I will start by asking Philip if he has any questions, and we will follow with a question from Stephen. I would pretty much interested to get from Stephen, which is addicted to Tableau. So I know he's wearing Tableau T-shirts, and he has a lot of Tableau in his house. So I was wondering if you can give us feedback on R. That would be great. So first, Philip, do you have any questions?
Yeah, thanks, Hendrik. Srivali, I was just wondering about the learning. Sorry, apparently I'm not coming. Is that a little bit better? I was just wondering about the learning curve for the software. Is it difficult to pick up or a little bit tricky?
In my experience, no, it wasn't really. Not really. It depends when you go to the other libraries. Like for instance, I talked about Plotly, but I talked about ggplot2, which is another library for visualization. So both of them were like completely different when I was getting started. Like I initially started with building charts using ggplot2. But then it's a very different way of building charts. Like you build like a data layer, aesthetics layer, geometric layer. It's very different way of building charts. And then when I switched to Plotly, it's not very layered. So maybe different packages will need different way of doing things. But overall, as R, I don't claim myself as an expert, but as far as I have explored so far, it wasn't like that hard to pick up.
Oh, cool. Yeah, thank you.
Any other questions, Philip?
Yeah,
No,
I
that's it,
just
thanks.
wanted. Oh, sorry, Phil.
You're on.
I actually think this is really exciting. I am definitely going to be implementing it in my work, which is a crazy thing to say, considering how much I love Tableau. But the thing that's really good about this is that I think now that you've shown this, there's no more excuses for people not to use a couple of years now. I think that's fantastic. But I do have a question.
Yep.
Have you found anything yet that R can't do, which Tableau can do?
Actually, it's probably easier the other way. Not yet. I mean, probably. No, I'm just kidding. Probably not yet because, like, to be fair, I'm still like guilty of using Tableau every now and then because whenever like I'm under pressure, which most of the times like I am, because I'm just so much used to it. So probably I haven't like explored R as much as like I'm doing stuff in Tableau, like tornado charts and things like that. So yeah, maybe it can be. Yeah, I can't. Yeah, I don't have an answer straight away, but I will keep you posted if I find anything interesting that I
Because that's
can't
the thing about Tableau is you can do things very quickly and adaptively. I wonder if when you know R really well and the code is just second nature, whether you could work just as quickly. That would be interesting to know. So if anyone out there that's listening uses R on that level, then let us know.
Yeah. But there is one thing that I think Tableau cannot do well, but R can do is all the data wrangling and manipulation stuff. Like in R, like literally you can melt the data, which means it will break down the data completely, and then you can format in the way you want. So you don't expect data to be in a specific format or anything. So all the table, like rows or columns, it doesn't have to follow any specific format. Even if it's like mixed up, you can clean it up and before you're reading the data. So yeah.
Yeah, and I'm not a big Tableau expert, but the fact that you expose it makes, from my end, I can imagine distributed process to play with the data, change the data, and then generate the graphs and the dashboards. So you can imagine like to what Stephen exposed, like I said, like a pipeline where you also prepare the future dashboards that will be utilized to analyze the successful build or the issue, or any default related to the pipeline, the builds to test through those dashboards. So I think it's pretty. I don't know if Tableau is able to do that central reporting mechanism as well, but that I think I see a lot of values behind that as well.
Yeah, I haven't used Tableau Server. Yeah, sorry.
Yes, maybe Stephen can answer. Is it possible to do that with Tableau, to have a central analysis component and then generate the dashboards or the graphs to expose it to the other members of your project?
Yeah, and it's built for the BI community. So you have this idea of you get this product Tableau server, you store all of your data centrally, and you can expose interactive dashboards, but also this concept of stories, which takes a person through a set of data and tells the story of what that data tells. And yeah, there's lots of stuff which I don't personally use, but there's huge potential there.
I got it. But does it require to have Tableau installed for every person that needs to look dashboards and data, or is it exposed?
No. In fact, there's also this concept of a viewer license. So your organization might have hundreds of viewer licenses, and then you view it in a browser. So I don't think so. I think you can get it to work pretty good.
Okay, makes sense. So yeah, it's a similar features that Tableau offers. Okay, super excited. So I think we should explore it a bit more, because I know that most of the people, when you're exposing Tableau, the first reaction is say, yeah, Tableau is great, but you need to have the good excuse to get the budget to purchase Tableau. So I think here now with the R, I think it's R Studio. It's a way to help organization that doesn't want to have necessarily the budget to get that type of tools in their hands. So I think that's pretty awesome. And also from my perspective, I see a lot of solutions from my end where I can do stuff that create graphs that we don't necessarily have in awesome load testing products.
Cool.
Any other questions from your end? No. All right. So I think we are 10 minutes ahead before Philip's presentation. So I will take advantage of those 10 minutes to grab another coffee. For me, it's currently my third coffee of the day. So we will keep that counter, and we'll see how many coffee we'll have at the end of this marathon. All right. So see you in a few bits. So let's have a small break.
Yes.